We did the basic rules of differentiation in the previous lecture. The rules we covered were derivative of a power function, derivative of a constant, derivative of a function with a constant multiplier, extended power function, finding the derivative of the sum or difference of two or more functions, derivative of the product of two functions, derivative of the quotient of two functions. These were the 7 rules that we covered in the first lecture. If you missed that lecture, please click the link shown on the screen to view it. The link is also provided in the description below. Let's continue today's session. We'll cover some more important rules. Rule number 8. Derivative of a function of a function. This rule is also called as the chain rule. If y is a function of u, let's say y is equal to f of u and u is a function of x, say u is equal to g of x, then how do we find dy by dx? Interesting. Here dy by dx is equal to dy by du into du by dx. That is, for this first equation, take derivative of y with respect to u and multiply it with derivative of u with respect to x. See, logically also, although we are not cancelling them, but in this equation, if you cancel the terms du in the numerator with du in the denominator, what you are left with is dy by dx only. This way of finding the derivative of y with respect to x is known as the chain rule. If there are 3 functions also, like if y is equal to f of u is equal to g of v, and v is equal to h of x, then find dy by dx. If we have to find dy by dx, then using the chain rule we get dy by dx is equal to dy by du, which is from the first equation, du by dv from the second equation, into dv by dx from the third equation. And now let's see some examples. Say y is equal to 3u square plus 5u minus 7 and u is equal to 3x plus 5. Find dy by dx. Now using this rule, dy by dx is equal to dy by du into du by dx. It means we'll need to find both dy by du and du by dx and then multiply both of them to get the final answer. So dy by du is equal to, we just need to take the derivative of this using the previous rules that we have studied in the last lecture. So dy by du is equal to 6u plus 5. Clear? And du by dx is 3. Therefore dy by dx is equal to 6u plus 5 into 3. Substitute the value of u, so we get 6 into 3x plus 5 plus 5 whole into 3. We have just put the value of u, which is 3x plus 5, in this equation. Then we get 18x plus 35 whole of this into 3. And the final answer, upon simplifying, we get 54x plus 105, which is dy by dx. Clear? Let's see another example. Y is equal to 2w square plus 1, w is equal to 2z square, and z is equal to 2x plus 3x square. Find dy by dx. So using the chain rule, we have dy by dx is equal to dy by dw into dw by dz into dz by dx. Alright. So first we need to find dy by dw from the first equation. We get dy by dw is equal to 4w. From the second equation, dw by dz is 4z. And from the third equation, dz by dx is equal to 2 plus 6x. So we write dy by dx is equal to 4w into 4z into 2 plus 6x. Substitute the value of w is equal to 2z square. What we get is 4 into 2z square into 4z into 2 plus 6x. Now substitute the value of z, which is 2x plus 3x square. In this equation we get 8 into, because this 2 came outside, so 8 into, in place of z we write 2x plus 3x square, whole of this square, into 4, put the value of z, 2x plus 3x square, into 2 plus 6x. Simplify this and we get 32, 8 into 4, 32, into 2x plus 3x square whole cube, because it was square here and a single 2x plus 3x square here, so we get whole cube, into 2 plus 6x as it is. So this is the answer. Rule number 9, derivative of parametric equations. Sometimes there are equations in which both variables x and y are functions of a third variable, say t. We can directly find the derivative of y with respect to x, that is dy by dx, using the chain rule. This eliminates the tedious work of substituting t in various equations to find the relation between x and y. As I said, we use the chain rule to directly find the derivative of function y with respect to x. See how. Suppose we are given functions of x and y as x is equal to function of t and y is equal to function of t as well. That is, both x and y are functions of the parameter t. Then dy by dx is equal to dy by dt into dt by dx. This is the chain rule that we studied in the previous rule. There is just one minor twist. X is a function of t, so we calculate dx by dt, that is the derivative of x with respect to t, and then take the reciprocal of that value to get dt by dx. dt by dx अगर आप देखो तो dx by dt का reciprocal ही तो है. Separately and through usual process we calculate dy by dt, because y as a function of t is also given. Once we get both dy by dt and dt by dx, we multiply them to get the final derivative dy by dx. अगर कुछ भी कंफ्यूजन है तो वीडियो के इस पोर्शन को थोड़ा बैक करके फिर से देखो. And now let's see some examples. Say x is equal to 5t square and y is equal to 3t square. Find dy by dx. So dx by dt is 10t and dy by dt is 6t. But we don't want dx by dt, we want dt by dx. So reciprocal of this, dt by dx is equal to 1 by 10t. Therefore dy by dx is equal to dy by dt into dt by dx is equal to 6t into 1 by 10t. This t and t cancel out, so we get 6 by 10 is equal to 3 by 5. If x is equal to 1 minus t by 1 plus t and y is equal to 2t cube plus 4t, can you find dy by dx? Okay, so dy by dx, using the rule we have dy by dt into dt by dx. So first let's find dy by dt. So dy by dt is equal to 6t square plus 4. This is dy by dt, 6t square plus 4. And dx by dt is, what rule will we apply here? The quotient rule, right? So we have two functions. If you see here, there is one function 1 minus t in the numerator and another function 1 plus t in the denominator. So when we apply the quotient rule, we get 1 plus t, which is the denominator, into derivative of the numerator, that is minus 1, minus numerator as it is, that is 1 minus t, into derivative of the denominator, which is 1, whole divided by square of the denominator, that is 1 plus t whole square. So we get dy by dx is equal to dy by dt, which is 6t square plus 4, into 1 plus t whole square by minus 2. Why? Because dx by dt we got minus 2 over 1 plus t whole square. So we just took the reciprocal of it. We get 1 plus t whole square by minus 2. When we simplify it, we get this 2 outside, 3t square plus 2 into 1 plus t whole square by minus 2. 2 and 2 cancel out. So we get the final answer as minus 3t square plus 2 into t plus 1 whole square. This is the answer. We'll end this session here. I'm leaving you with some practice questions. Try to solve them on your own. If you face any difficulty in any particular question, please let me know in the comments. I'll try to solve them for you in one of the future lectures. Thank you. Bye.